Welcome, Hornets. Thank you for joining me today. Today I'm going to be taking a look at our reciprocal of the derivative of the inverse of b, which is how we find derivatives of inverse functions. And I've got a few problems here that we're going to go through. There are 4 of them. And I need you to remember that whenever we're trying to find a value, such as in number 1, g prime of 5, we have to remember that when we're talking about f, the 5 is the y value. So whenever we're looking at it, we're saying, if I have an f that is equal to 5, I may have to use the function. And if they give me a function, I'm going to have to set it equal to 5. And if they give me the values, I have to remember that the b value for g of x is the x value in f, as we see here. So we're going to be using g prime of 5 is equal to the reciprocal of the derivative of the inverse at the b value. Now in the problem that I've given you all of the information, and all you have to do is get used to the process of direct substitution. Notice we end up getting a negative 1/3 using the RDIB, the reciprocal of the derivative of the inverse at b. Now, in number 2, it's a little bit more difficult because now I'm giving you the function and I'm saying, well, what if I have negative 2 as the g? Well, that means that I'm looking for what value of f goes in that will yield negative 2. And this requires me to think about it. It's usually a small value. 1, 2, 3, negative 1, negative 2, negative 3, something like that. Okay? So don't try to make it too hard and look for greater values. So when I look at this and I say, what is going to make negative 2 from x to the 8th, which is an even power, minus 4x, which is an odd power? Well, plus 1. Now I'm going to want to think about it. If I have a 1 going in here, or a negative 1, I would end up having a 1 plus 1 makes 2. But if I had a negative 1, that would make that a positive 4, and I would end up having a 6. That forces my x to be a positive 1. Now, once I know that f of 1 equals negative 2, I can immediately begin the process of finding my derivative, and that means I want to find the derivative of f at 1. So what is my derivative of f? F prime of x is going to have to be 8x to the 7th minus 4, and when I plug in the 1, f prime of 1 is going to end up being 8 minus 4, and I end up having a 4. So f prime of 1 is a positive 4, and my answer is 1/4. Okay? Let's take a look at number 3. F inverse prime of 5. So 5 is that y value, and we're looking for the f that will yield 5. So I'm going to immediately look at 5 equaling my 3x to the 4th minus x cubed plus 1. So let's think about what we have here. I want to get a 5, and if I put in the negative 1, that's going to make that a 3 plus 1 is 4, and negative 1 cubed is negative 1 times negative 1 is an additional 1. So I found it, negative 1. We're then going to want f prime of negative 1, so let's first find our derivative, 12x cubed minus 3x squared. And when I plug in that negative 1, I'm going to have negative 12, and I'm going to have a minus 3. Negative 12 minus 3 is negative 15. So my f inverse derivative at 5 is the reciprocal of f prime at negative 1, which we have found to be negative 15. So my answer is negative 1 over negative 15. And that's my answer. Then sometimes they give us things in a chart, And instead of giving you a chart, I've broken it down and given you different information. So if I want to start by saying f of what is equal to 2, and I'm going to look for f of what, and I find f of 3. I'm now going to set up the reciprocal of the derivative of the inverse at b. So I have 1 over f prime at 3. So I'm now going to find what f prime of 3 is. It's giving me a negative 1/3 in the denominator, which will end up being a negative 3. There's my first answer. If I have g prime of negative 1, I'm asking what value of f gives me negative 1, and I find that to be a 5. So I want 1 over f prime at 5, and I'm now going to find what f prime of 5 is. And I find a 7, and my answer is 1/7. Okay, so here we see 4 problems, all asking us to do the same thing, and in each case I am using the reciprocal of the derivative of the inverse at b. Now keep in mind, if they give me a function where I can easily find the inverse, it is just easier for me to find the derivative of that inverse and plug in the value. This happens with lines and simple cube roots or cubics, simple square roots or squares, things that are easy to work with. Now keep in mind, RDIB is a choice. If you can easily find the inverse, you can take the derivative and plug in the value, and you don't have to work with RDIB. But most of the graphs and most of the functions that we will work with will not have a function, an inverse that's easy to find. And it'll take you more effort to find the inverse than it will to use the RDIB. I hope this has helped. If it has, please remember to click like. If, however, you have found this to have problems with it, please make sure you give me constructive criticism. Thank you very much, Hornets. Please be safe, take care, and have an excellent day. Bye-bye now. Cheers.